So you're doing mapping of an area and you're doing high spots everywhere. Church steeples, mountaintops, whatever. On some mountaintops, someone went to the massive amount of effort to go up to it and put a stick at the top that, you know, so you could find it just to get the right and left angle and up and down angle kind of close. All that work, all that energy, because people want to know how to navigate the Earth. Over the oceans, you have to use whatever you can get away with, and you hope that you can find a high spot somewhere to zero in on, but a lot of empty space. You do all that work, and you're aware of the fact at the time that since 300 BC, we've known that the Earth is a sphere, and that you have to deal with it as a sphere. So here's our triangles. Now, in every case, you try to do a right triangle or something like that just to make the math easy, but you do what you got and you take what you can get. Obviously, from here to here, you could put in another line and make a right triangle. So anyway, one day you go out and you're resurveying, you know, some farm plots. This is a farm plot and this is a farm plot going around, let's say, the curvature of a river. And you're a tax man. Well, it's a big section of ground, and you notice that if you start at this end and then start at this end, there's this error at the bottom where part of the map seems to disappear. You see, it really is this, but if you do these triangles, they have 180 degrees per triangle. It's the way it has to work mathematically. This isn't something where you get to square the circle and round off pi d equals 4 or whatever. You have to deal with this error, and it's an error. Ladies and gentlemen, that's an error where someone could get into problems. You see, now Farmer Brown and Farmer Blue have to argue over which one of us gets to pay for a chunk of dirt that isn't there because someone wants to draw a line straight in the middle. And you say, well, put it on his border, not on mine. And you have to explain to him, no, we're not going to do that. That's just where the map breaks up. You see, the Earth is a sphere, and when you draw the map, no matter how well you draw it, it's going to either be distorted or it's going to be broken up, because it's like peeling an orange. It has to do this. Now, to the average farmer, they know everything's square and everything. Well, that's nice, but over a large area, it may be square, but over a really large area, it gets more towards it being not straight lines on the edges. They're straight lines from one perspective, but not another. And it takes a little work to think that through. But all anybody sees is someone trying to tax me more for my property by charging me for a sliver of property that isn't there because the map's wrong. Well, the map isn't wrong. Attempting to draw a flat surface on a map from a spherical or not completely smooth surface planet causes problems. This also happens the other way around, where you get cross-ups in valleys. You run into this when you're doing video game editing too. So how do we fix that? Well, we acknowledge it, and you have to deal with this error. Remember, the curvature of the Earth to a map maker is just a damn error they have to deal with. So you got two choices: draw a distorted map and then put a note in there that says this is not drawn correctly, or cut the map up into pieces so that the squares are actually square enough that you can get away with it. Or two, acknowledge that if you do plane surveying, a triangle is going to be 180 degrees, and geodetic surveying that actually deals with the Earth itself is going to have a little bit more than 180 degrees of arc. And sometimes you can measure this over pretty small distances. But here's the thing. The curvature is discovered, not made. It's not manufactured. This measurement error was observed, and then it became a pesky problem to deal with on map making. It's called spherical excess measurement. I've stolen this frame, by the way, from Geodetic, Surveyor. Jesse can't pronounce it, straightens out the flat Earth. And I'd like to point out that a certain Lord Stephen Christ, a lazy man, critiqued his video in many ways. But he was basically quote mining because he's talked about the one thing I would have a problem with. This guy did a measurement over a 1 mile distance, which is not long enough to really get a really good idea of the Earth. I have a problem with that, except for one thing. It's consistent that if you do this measurement every mile, you'll get a very odd thing. You'll get consistency that happens continually. For every mile of distance, you get about 0.8674 arc minutes of error off of being plumb. Now that's just big enough that you can actually measure it. Or more accurately, 1.15 miles per arc minute of error. Now I'm calling it error. I'm not calling it the curvature of the Earth. I'm calling it an error. If you're doing map making and you're trying to figure out taxes and you're trying to draw lines on a flat map, you don't want to deal with the curvature of the Earth. but it's consistent at 1 arc minute per mile almost. It's big enough you have to not ignore it. You can't. Even at 1 mile, 5,280 feet, you will run into this. Now, the reason for that is pretty simple. There's 21,600 arc minutes per circle, and the Earth is approximately 24,901 miles in circumference. And that is consistent with its average diameter of around 7,917.5 miles in diameter. So it's consistent and shows up almost everywhere. Unless you're looking at an area that looks like a flat dent in the Earth, you're going to run into this. It doesn't go away. You can't wish it away. You can't pray it away, and you can't argue it away. It exists. Now, I, of course, object to it being done over 1 mile. But then I realized something. All of you patriots out there that want to think the Earth is flat, who talk about how you're a guerrilla sniper who shoots bananas because you misspelled gorilla, all of you love saying that you can fire accurately as a sniper at 1 minute of arc. 1 minute of arc is too small of an angle for me to tolerate. I'd want this guy to measure 10 miles, but he didn't want to do it. He just wanted to do this because it's good enough, because it's consistent. He didn't do double, quadruple redundancy. He did 6 times redundancy on some of these things. And he was able to detect it over a fairly reasonably short distance of 1 mile, and it is consistent, or it should be. So all of you guerrilla sniper banana shooters who claim that you can hit at 1 minute of arc, being able to hit the shell casing of a bullet at an extreme distance, you know that on a real meat and potatoes level, 1 minute of arc is something you understand. All right? All right. So if it is, then you can acknowledge that if you see it repeatedly, it's well within tolerances of error. Now, over a 4 mile distance, the angle change on a 1 meter stick is approximately 1 millimeter. And you can screw that up by using giant rulers and stuff. So what was the excuse Lord Stephen Christ used for ignoring this? He says light bends. He always says that. He doesn't prove it. He doesn't show proof of it. He just keeps saying it. Okay, light bends, sure. Okay, but you can measure this over a 1 mile distance, not 4. And you can find conditions where the bending isn't going to be that bad, but it's consistent everywhere? Oh, okay. So your excuse, your Deus Ex Machina, claiming to be a deity, by the way, is you're going to be a lazy, arrogant, fat earther, light bender, quote mining, a geodetic surveyor who just didn't do a longer distance than a mile, and some other things you're going to complain about in your video. Okay, well anyway, this error, this pesky curvature, wasn't made, it was observed, and it's been observed over a long distance of time and long distances. And the video I'm pointing to, where the geodetic surveyor, Jesse, I can't pronounce it, posted, explains this in meat and potatoes way. You can ignore it if you want, but by ignoring it, you're acknowledging you don't want to know. You want to stay a sheeple. A series of triangles used in triangulation surveying is called an arc of triangulation, and these things have to absolutely accommodate for the fact that they get accumulated errors as well, and that accumulated error looks like that. Even though you can mechanically test it each direction, all you can do is move this little error around, and I can just see somebody trying to create bent triangles to fill it in, and it's caused by the curvature of the Earth. And it can be detected over long and apparently fairly short distances. Now, here's my problem. The equipment he's using is accurate to 1 minute of arc, or even less. Most of you shooters know about 1 minute of arc, or at least claim to. You cannot have it both ways. And Lord Stephen Christ can't have it anyway because, unfortunately for him, it's a consistent response to the shape of the Earth not being a concave item. It's a convex item. There's too much consistency and too much concordance, yes, I'm using that term, across the board from multiple sources. And yes, somebody would love to take advantage of this and change your tax codes and charge you for that little sliver of land. But it doesn't work that way because this has been understood since 300 BC. And we've understood this for too long. There's too much data. And I'm going to critique Jesse. He should have done more than 1 mile. He should have done over multiple distances, east, west, north, and south. Should have done it from mountaintop to mountaintop. He should have done all that work, or he could just respond to the fact that he wasn't going to let idiots keep him busy and just post the facts. If you're going to be lazy about critiquing him, don't do so. Credit is given to Jesse for that image. I think it's this one. I've modified it somewhat because I'm treating this as an error that is observed. As an error that is observed and is explained in only one way, because it doesn't fold in except in really, really limited circumstances. Statistically speaking, these errors add up to a round Earth, a sphere, not a concave and not a flat surface. Thanks for watching. Have a good day. Good luck with that.